That means it's the reference angle. Okay. And then we got to, depending upon which the quadrant lies, we affix the appropriate sign to the function value. Just like we did in that last homework problem. We decided what quadrant we were in, then we decided what sign was appropriate for that. Because technically, when you take the square root, it's a plus minus. You got to figure it out. Okay. All right. So these we have done before. So this is kind of review. I'm going to review the first one with you, and then I'm going to have you do the last two times on your own. Okay. So you're on your unit circle. Okay. You tell me which quadrant is 4 pi over 3 in. Third quadrant. Okay? So in the third quadrant, what is it? Read me the coordinates of it. What does it say? -1/2. Okay, I like that. And what's the other part of the coordinate? Good. Perfect. Now what they're saying is, hey, find the sine, the cosine, and the tangent of that angle without using your calculator. So, and pretty much know that we're not going to use the calculator when it comes time for calculus for any of those things. Okay? All right, so sine of 3 pi over 4 is sine the x value or the y value? The y value is that one right there, right? So negative square root of 3 over 2. Cosine of 4 pi over 3. All right, and was that the x value or the y value? X value, so negative 1/2. And then the tangent of 4 pi over 3. So I put my signs back up. See the purple, the pink sign, the purple, pink, yellow. This one has yellow. I don't lost my yellow. The purple sign has that identity for the tangent, right? So the identity is the sine over the cosine. The only time those signs will be up there is if you're S back. Okay? For S back, by the way, second period, you guys are staying with me. Technology for pushing something else. It's incredible. Some other teacher. They told me it's going to be interactive. So I have to teach the lessons third period. So we'll see. Alright. What is the cosine then? I'm sorry, the sine. Negative square root 3 over 2, and the cosine is negative 1/2. And then the double negative goes positive, and then what else can we get to? We shortcut it and cancel out the 2, so I'm really just square root of 3 over 1, or and again, does it make sense in quadrant 3 that my tangent's positive? You always can check that, right? Because we understand which ones are positive or which ones. Yes. Yes. And remember, no, cotangent is cosine over sine. Tangent is sine over cosine. Okay? And we're going to write that down again today. Okay. All right, let's take a look at 14 and 15. I'm going to start you, and then you're going to do it. Okay? Is negative 210 on your unit circle? Negative is not, positive is, right? So what do I have to do? Add 360, what do you get? 150. Okay, so we've got that piece. You should be able to do it from there. Now look at 15 before you do 14. Is 11 pi over 4 on your unit circle? No. How do I get it on the unit circle? Subtract 2 pi and over 4 worlds, what's 2 pi look like? 8 pi over 4, and we end up with, so 3 pi. So what you need to go do now is for both 14 and 15, find the sine, the cosine, and the tangent. Okay, I'm going to give you 2 minutes, maybe 3 minutes to do those 2 problems right now. Okay, so everybody's doing it. They should completely do it. I should only have to go through it. tangent of -210, check your sine and divide it by your cosine, and what did you ultimately get? But if I don't need to do any more with it. Alright, let's look at 15. So we're technically looking at sine of 11 pi over 4. Okay. So what did you get for the sine of that? Alright, that's 11 over 4 is 11 radians, right? That's easy. What about cosine? Good, and then the tangent, 11 pi over 4, you gotta go to the sine, right? Divided by the cosine, again, reduces to. Alright, okay. Alright, we're going to look at something that you looked at Monday with right triangles, and today we're going to put it into using the trig identities. So these ones I hung back up, they're some of your trig identities. There's lots of trig identities, but there's some of your trig identities. Okay? So we are going to take a look at those. So this one we don't need, we just are going to use reciprocal on this one, okay? To be able to get there. So I should use our unit circle on this one. Alright, so you've got your unit circle in front of you, hopefully. So we're going to look at the unit circle. And for the unit circle, is the sine the x value or the y value? Y values. And it says what quadrant we're going to, right? So what I'm going to do is I recognize 1/2. And the reason I'm using my unit circle is I recognize 1/2 as the unit circle value, right? If there's anything other than that, I'd have to pick another way to do this. So I'm looking at 1/2 in the y. I've already got it on mark there. Looking at 1/2 in the y, what radian measure are we at? 5 pi over 6, and then what does that mean that the cosine is then? -square root of 3 over 2, right? So what I did was, hey, I found, oh, this is at 5 pi over 6, and I know that this is then has to be -square root of 3 over 2. A lot of thinking, but was there a lot of writing? No. Okay. Now we're going to put this in a slightly different context. I'm going to change the problem a little bit on 17. I'm going to make it secant, not cosecant. Okay. Now, our 13 over 5 are those unit circle numbers? No, right? So I got to find some other way to do that. You should know, based on Pythagorean theorem, you should know your Pythagorean triples, right? 3, 4, 5, 6, 8, 10, 5, 12, 13. Do you see these numbers popping up here? Okay. They pop up all over the place. There's others. Those are the ones that we use the most for those. And notice that this one is just this one times 2. Okay. And we could do it times 3, times 4, and so on. But you see these numbers pop up a lot. So we're going to have to use our other identities. We're going to use the pink sign. But we haven't written that down anywhere because I skipped a lesson. Because I did the right triangles and down. We don't need to do this again. But this was in that lesson. So I need you to flip back like 2 pages in your notes. And that box should be there. Am I right? About 2 pages? Should be at the bottom of like the page, maybe 2 pages back. It should say fundamental trig identities. Maybe the page 2 back. 3 pages back. So page 72. Okay. Go ahead and fill in those boxes for me right now. We're going to use those, and then you at least have it written somewhere. Give you a minute to fill it in. notice I put the signs back up on either side on the windows. That's the purple sign. Okay, well, that's the hardest one to read, but we should know that one. It will be there when you take your test on this. Okay, so you don't need to worry about memorizing it. Right? And then we have these new ones called the Pythagorean. They call them the Pythagorean because it's something squared plus something squared equals something squared. Because 1 squared is 1, right? That's why they call them the Pythagorean, but they relate things together really well. It relates the sine to the cosine really well, tangent to secant, and cotangent to cosecant. So depending upon where you start and where you need to go with it, you can, if you started with a secant and you need to get to a tangent, you want to use this equation, okay? Because it gets you there faster than maybe even doing the right triangles. You can always default to the right triangles. Using that identity is just another way to do the same thing. Okay? We're going to practice that. All right. Let me get to this one. So it says, hey, we're starting with secant, and I got to get to tangent. I know that I have an identity that does that for me, right? Oh, let me explain the pink sign really quick, too. So there were only 3 Pythagorean identities, right? The pink sign has 9 things on it, doesn't it? So what I have done on the pink sign is if you look at the first column of the pink sign, it's the things you wrote down, except it says u's instead of thetas. Okay? Doesn't matter whatever variable we throw in there. And then do you notice how the second column, all I did was rearrange it. So if you look at that first equation, I took and I subtracted the sign over. So it's cosine squared equals 1 minus sine squared. You don't have 9 things to memorize. Okay? How to know the first column, you can always rearrange the first column to get to any of the second 2 columns. Okay? The third column I took, for the first row, I took the cosine and I subtracted it. Okay? So it's the exact same equation, I just manipulated it. When we get a little deeper into this, I use that sign for other things. Okay? All right. So we've got the what should we call it? So I'm going to use the trig. This first column, the second equation there. So 1 plus tangent squared theta equals secant squared theta. Just solve for tangent. Okay? And I could use any of the ones in that row. I could use the one that says tangent squared equals secant squared minus 1, but I'm choosing to do this one because I know I can get my algebra to solve for it. All right. So do I know what secant is? What is secant? Negative 13 over 5. I'm going to plop that in there for secant and square it. Remember when we write the squared for a trig, it goes on the piece of trig. That way it doesn't look like you're squaring the data. Okay. All right, so I'm not going to write the 1 yet. We'll see why in a second. So what's negative 13 over 5 squared? 13 squared. Sign's right there. 169, what's 5 squared? Well, we should know what 69 is. Okay. All right. Eventually, I'm going to have to take that 1 and subtract it over, don't I? But I need a common denominator of 25, so shouldn't I write it as 25 over 25? Save myself some more. The nice thing about this equation is it's ones, and ones are very easy to make with little fractions. Okay? So what am I going to have to do with that 25 over 25 now? Subtract it to the other side. Okay, so when I go to the other side, it's 169 minus 25. 144. And then how do I undo this square? Square root, and technically when I take a square root, it is plus or minus. We're going to talk about that here in a second. So we're right on that line, but on the next time we're going to examine the root. What's the square root of 144? Well, what's the square root of 25? Remember how I said it was a 5, 12, 13. You see how that 12 popped up in there? Okay, so it's all connected. Alright, we have to decide if it's positive or negative. So in quadrant 3, and you can look at your unit circles. Okay? In quadrant 3, is tangent positive or negative? It's positive, so I know it's positive. calculations. And again, I'm not going to use triangles, I'm going to use my identities. Okay? So technically it's over what? 1. Alright, and before I go much further, I'm going to identify what quadrant I'm working in so I know that I'm making sure that my positive and negatives are all correct. So this is saying that the cotangent is a negative, has a negative 1. So which quadrant is cotangent negative in? Second and third. Perfect. What is this saying about sine? Positive is greater than 0, right? So greater than 0 is positive. So out of these two quadrants, which one is sine positive? Second. So I know all of my answers have to fit quadrant 2. Alright. They gave me cotangent. What do I get for free? Tangent. And all I have to do is flip it, right? And again, that doesn't matter where the negative goes. Alright. I have to get my other 4 now. But once I get sine, don't I get cosecant for free? Once I get secant, don't I get cosine for free? Right? So I only really have to pick out 2 more, and then I get the other one. The reciprocals are easy. Right? As long as I get a reciprocal on it. So look up at the pink sign. Is there a formula for tangent that has a tangent to it? Read it. What's it say? We're in the first column. What's it say? 1 plus tangent squared equals what? Secant squared theta. Okay, you have those formulas in your notes, and they're in the front cover of your notebook. Okay, and probably the front and the back of your book. They're in the it's in the back page of your book. Okay, so if you flip over that hard page in your book, they're all right there. Okay, so this page is photocopied in your notes notebook. Okay, so you got it. All right, I'm going to substitute in the tangent. So what's going in for the tangent? Negative 1/5. All right, what is negative 1/5 squared? 1/25 equals secant squared. I should not have written the 1. What's a better name for my 1? 25/25. All right. It's 25/25 plus 1/25. 26 over. Oops. 25. How do we undo the squared? Square, and we don't know. We have to examine whether we're going to use the plus or the minus. We're going to leave it as square root of 26. What's the square root of 25? 5 equals secant squared, or secant of theta. And actually, I don't want to put the plus minus on it. I'm going to try to figure that out. Okay. So if I'm looking at plus minus, I'm in quadrant 2. Should secant be positive or negative? It should be negative, right? So it's going to have that's a minus sign. That should be minus sign. All right, I've got secant. What do I get for free? Cosine. I just have to flip it, right? So negative 5 over square root of 26. Oops, now we're rationalized, right? So negative 5 square root of 26 over 26. Let you catch up. So I'm looking for something that relates to cotangent. Either I can do this cosine, the sine squared plus cosine squared equals 1, but this is really ugly, isn't it? This is much better. So I would use the one with the cotangent in it. So I want you to look at the pink sign. Everybody's looking at the pink sign, and I want you to read me the formula that has cotangent in it in the first column. What does it say? 1 plus cotangent squared equals cosecant squared theta. Right? Okay. What is the cotangent right now? Negative 5. Good. And then the cosecant is what we're trying to solve for. secant, cosecant, we're in quadrant 2. Quadrant 2 is cosecant positive or negative. Again, it doesn't hurt to write the plus sign, so you know to check off that box. Technically, what's in the denominator? 1. Why is that important? What am I going to have to do next? I got to flip the reciprocal, right? So I got to, because I know secant, cosecant is the reciprocal of sine, so sine is 1 over square root of 26. And then we have to rationalize it. Told you when we started trig, we're going to rationalize 4 million times, right? Just think about it. I've been doing this until I didn't teach algebra 2 my first year. But I did teach geometry, which one goes a lot of questions. So I've been rationalizing it like 5 times a day. 19 years. It's a lot of rationalizing. You see why I do this so hard? Okay. Okay. And that doesn't include what the classes I take at high school. Alright, let's look at 19. Actually, no, we're going to skip 19. I'm going to skip over these ones. I don't think we need to worry about this in our calc that are definitely don't need to talk about this. We do need your unit circle, and we're going to look at 22. Okay? This is important that you can reverse this. So what they're asking us to do is they're asking us to figure out what the radian measure is and what the degree measure is. So we're going to solve for theta. We're trying to find the angle using our unit circle. Okay? And this is a skill you really need to have walking into next year. Okay? So on your unit circle, is the cosine the x value or the y value? X value. So on your unit circle, I'm going to try to flip back to my real quick so I can do this one now. So what I'm only going to show you one with unit circle, the rest of them you're going to read on your own. I'm going to walk around my unit circle, and I'm going to look for where the x value is positive square root of 2 over 2. So do you see how it's at pi over 4? Which is also how many degrees? 45. Okay, then I'm going to keep walking, up. It's positive right here, isn't it? So what radian measure is that? 7 pi over 4, or how many degrees? 315. Alright, so that's what I'm going to write down. This one. So I'm going to say, all I have to do is write down the angle measure. So we said it was pi over 4? And that's 45 degrees, and then we said 7 pi over 4, which is 315 degrees. That's it, that's all I got to write down. Okay, so it's not nearly as complicated as the last bunch. Okay. Let's take a look at 23. So this one is now saying we need the negative in front this time. So I'm going to let you walk around the unit circle yourself. Is cosine the x value or the y value? X value. So I should be looking in which 2 quadrants for a negative cosine? 2 and 3. So look in quadrant 2 and 3 for your x value being negative square root of 2 over 2. What are we seeing for our radian measures? 3 pi over 4, which is how much in degrees? 135. Alright, and then what do you see for the other one? 5 pi over 4, which is how much in degrees? 2 what? 225. Not so bad. Now it's going to get a little uglier. Okay? Sine and cosine are easy, but they're not always going to give us sine and cosine. They might give us cosecant or tangent or anything. So I have to build those up a little bit and put them back in terms of sine and cosine. What's always in the denominator? 1. What's the reciprocal of cosecant? Sine. So you see how I'm getting it back to a sine? Because I know I can find sine of this. So sine of positive 1/2. What quadrants is sine positive? 1 and 2. So look in 1 and 2. Is sine the x value or the y value? So you need to find the y value. We look for the radians and the degrees of where the y value is equal to 1/2. So what is it? The first one in radians. Pi over 6, and in degrees that is. Pretty good. All right, and then what's my other one that's in quadrant 2? 5 pi over 6, and in degrees that is. So it's also going to work that way for cotangent, which you have to apply whether it's a cotangent or tangent. So, what is always in the denominator? 1. And I'm trying to build this back to being able to figure out sine and cosine. Okay? Look up at the purple sign. What do we know about cotangent? What is it? Cosine over sine. Okay, but to get back on the unit circle, remember when I would have had the square root of 3 and 1, I would not have had that. I would have had to reduce it based on what's on the unit circle, right? So it's really that. What's really in the denominators? 2's, right? Because I would have canceled them out to go back to this, right? So really I'm looking at that. Ooh, but does the negative have to go on the top? Could the negative be on the bottom? Yeah, so what I am looking for is negative square root of 3 over 2 1/2, right? Because this is my x and this is my y, because it's cosine over sine. Or I am looking at square root of 3 over 2 negative 1/2. Those two specific points. So find those two. Write it down. Everybody write down both the degrees and the radians. Okay, what do we get for the radian measure? This first one. Pi over 5 pi over 6, which is how much in degrees? 150. Alright, and then what else did we get? The other one. 11? Is that right? 11 pi over 6, which is 330? That guess right? Alright, that's where I'm going to stop. What I did, okay, was I adjusted your homework because we did the last 2 days to start relating the unit circle to sine and cosine, right? The curves. We're going to see the next couple of days. Okay? So I adjusted the homework and made it so that you didn't have anything extra for those days. Really. I adjusted it under where it says Trig chapter 1. I moved the assignment from the data board here. So from the Monday assignment, I went and I split it into 61, 62. So if you did the Monday assignment, you got 62 done. Okay? And then for today, I basically took the one assignment, I split it into 2, 63, 64, and then whatever I give you tomorrow, I'll just do that. Okay? Next week, we're heading into like the week before SMAC, right? So we need to hit the IABs hard next week. Okay, I'm going to give you your scores back and maybe retake a little bit. I know some of you didn't do the trig one. Okay, remember I told you if you go green, right, or you improve your score on 4 of them, then you guys, you don't have to, and keep an A, you don't have to take the final, right? So we'll work on that. And the other thing I want to go over with you guys is I want to step you through the performance task that they have out there, just so you guys have seen it, how to get your brain wrapped around what the performance task is with them, right? So that's my plan for next week, and then as much as we can, we'll embed the trig into. Okay? I might just do. I'm kind of thinking of switching the graphing to all of Desmos and not doing graph.